favorite atmosphere? Me, personally, I'm partial to like smooth jazz and some soft firelight. Make English joke done? Okay. But seriously, when we're talking about science, I asked this question to some colleagues and some friends over the last week, and they looked at me with blank stares on their faces, and they said, honestly, Glenn, I've never really thought about it. Which is a shame when you think about it, because atmospheres are fascinating. Not just ours, but all of them. They're what separate the planets from the inhospitable, terrifying world that exists outside in space itself. I want to talk to you about atmospheres so that we can have a better discussion and maybe you can formulate your own opinion on them. Before we talk about atmospheres, though, we need to talk about the solar wind. Charged particles that fly off the sun, plasma really flying at 900 kilometers per second, and push on much of the matter that exists in our solar system. And the lighter an element is, the more it gets pushed farther and farther out. That's why we get gas giants on the outsides of the solar system and not close near the sun. Speaking of gas giants, let's talk about the first four. Well, the ice giants first, Neptune and Uranus. They're cold. They're filled mostly with water ice and ammonia ices, hydrogen, helium. Neptune has winds of over 2,000 kilometers per hour that we've measured, and is surprisingly interesting for planets that are so far out. But they're not as interesting as planets like Jupiter and Saturn, what we typically think of as gas giants. The atmospheres on these planets are massive. Jupiter, besides being a fantastic visual representation of the Navier-Stokes equations, also has the Great Red Spot, a massive storm that's been brewing for 500 years at least. Jupiter also, when you get farther down, has high enough pressures to produce liquid metallic hydrogen in its atmosphere. And it's thought that the cycling of this liquid metallic hydrogen is responsible for a magnetic field 20,000 times stronger than Earth's. Pretty impressive, I know. But what about Saturn, I hear you say? The rings, the gas in general. Saturn, though it doesn't have a great red spot, has something we call a great white spot. Massive 10,000 kilometer diameter thunderstorms that come up in the northern hemisphere during Saturn's summer equinox. And that only happens once every 30 Earth years, but it happens like clockwork. One of the things that we often talk about when we talk about atmospheres is surface-atmosphere interaction. The surface of a gas giant is a little bit difficult to pin down because scientists determine the surface as where the atmosphere pressure equals 1 bar, but that's kind of boring. In reality, if you tried to jump into Saturn, besides dying, you would sink through the atmosphere until the pressurized gas, the density of the gases, ended up being such that you would start to float. And there would be a buoyancy force, and you would suddenly enter an ocean. An ocean of gas, though it's maybe difficult to visualize, that is the surface of these gas giants. This is in contrast to the terrestrial planets, the ones closer to the sun, that have had all of their atmosphere blown off violently, kind of like that. These planets have heavier elements in their atmosphere. Mercury has stuff like sodium, which is kind of insane. Venus, very famously, has a CO2-dense, rich atmosphere. And temperatures and pressures that are absolutely insane. It's like if you were standing on Venus, you're 1 kilometer beneath the ocean on Earth. This causes the refractive index of air to go up really high, and because it's so hot, you get heavy metal frosts that appear on the poles of Venus, just like we get water frosts here on Earth. Skipping over Earth because it's a little bit boring, we get to Mars. Mars has a very thin CO2 atmosphere, not like Venus, but it also has some interesting polar features. You see, as Mars gets far away from the sun, it gets really cold. And the CO2 in the atmosphere condenses out into ice caps at the poles, which happens to drop the atmospheric pressure on Mars by 15% throughout its perihelion and aphelion cycles. Kind of insane. I could have more time and talk about this for a long time, but I wanted to get this information across to you so that we can have a meaningful discussion about atmospheres, and maybe one day you too can answer the question, what's your favorite atmosphere?